All right, so hey, something's come up. My plans have had to change here. I was planning on teaching some stuff tomorrow that I'm gonna end up having to teach today. 'Cause I'm not gonna be here tomorrow. So tomorrow's gonna be a full work day for you. Today I want to get through a few just kind of different odds and ends, and then you got stuff to work on tomorrow. So we left off yesterday. We did a big factoring review, right? So we ended up talking about what do we do if A is not equal to 1? If A is bigger than 1, and I'm stuck with it. I can't, we looked at an example here where we're able to just factor out the 2. We had a greatest common factor of 2, and then we're left with a simple trinomial to factor where A is equal to 1. See what I'm saying? So that one was easy. By factoring out a greatest common factor, we made it simple. This one, we're stuck. We can't factor out a 2. And so we have 2 methods for doing that. Raise your hand if you're comfortable, like you know how to do bottoms up. Okay, so a few people. So let's go through the rules on bottoms up. So, and I'm just going to start this one over. So 2x squared minus 15x plus 18. Let's start this one over. That was it, right? Yeah. Okay. So to do bottoms up, here are the steps for bottoms up. For bottoms up, and I've got a handout that I'm going to put online that kind of it's a review that takes you through all the steps for bottoms up. But you'll get this. This will come back to you. So we have to find our magic numbers, and we're going to do that in almost the same way we did before. Only this time we have to find magic numbers that do 2 things. They have to multiply to A times C, and they have to add to B. Okay? So A times C in this case is 36, and B is negative 15. So I got to find those magic numbers that multiply to negative 36 and add to negative 15. What are they? Negative 3, negative 12, right? We can play the sign game. We know that they're both going to be negative because they multiply to a positive and add to a negative. So negative 12 and negative 3. So there's step 1 in bottoms up. We got to find the magic numbers. Step 2. We're going to set up our template for our factors. So that's always going to look like, I've got 2 quantities for both of my factors. This is going to be an x, that's going to be an x, and then I'm going to combine the x's with these magic numbers, right? So I'm going to get x minus 12 and x minus 3. Okay. Step 3 is going to be that we are going to, whatever our coefficient is, so in this case, A equals 2, we're going to divide each of the magic numbers by 2 and reduce if possible. So we end up with x minus minus 12 over 2 times x minus 3 over 2. Okay, and then I can reduce that, right? So that's going to become what? X minus 6 times x minus 3 over 2. Okay? And then finally, the last step in bottoms up is if you have a denominator, if you're left with any denominators, all remaining denominators go bottoms up. Okay. And what that means is they're just gonna go up to become the coefficients of x, right? So we end up with the answer, x minus 6 times 3. Sorry, 2x minus 3, whoops. 2x minus 3. Okay? Does that ring a bell?
Yeah.
Okay. Okay. So that's bottoms up. That's the way you were taught in Algebra 1, I'm almost certain, right?
Yeah.
Okay, I'm going to show you a better way to do this. This is, the problem with bottoms up is that it's not algebraically sound. You're setting up some equations here that aren't equations, right? Well, we'd call this hand waving in physics. This is not equal to that, is it? Nor is it equal to that. Nor is it equal to that. What we started with is only equal to what we get in the very last step. It's not equal to any of the intervening steps, which is why I really don't like bottoms up. It's not a truly algebraically rigorous process. I mean, it gets you the right answer. It's kind of a trick, is really what it is. Okay, here's a better way to do it. Now, the first part of what we do stays the same.
How did we get negative 12 and negative 3 again? I can see how I got 15.
Those are the numbers that multiply to A.
Multiply to AC and add to B. Okay.
So we're, okay. So it's A times, okay, I got you.
Okay, so everybody with me here? You gotta really focus on this, because this is a better way to do it. And I have another reason for showing this to you, because the technique I'm going to show you is called factoring by grouping, and you're going to need to know it anyway, because when we factor polynomials bigger than quadratics later in the year, this is a way that we do it, right? So it's something you're going to need to know anyway. It's a great little technique. You might as well know it now, because it's useful. So we're going to go through the same process of finding the magic numbers that we did before.
What did you call it?
Factoring by grouping. This is called factoring by grouping. Okay, let's label that actually. Why not? Okay, so here's what we do then. Once we find the magic numbers, we're going to split up our trinomial into, we're going to split the middle term into 2 separate terms. So we're going to get 4 terms instead of 3. When you use factoring by grouping, you always need to have an even number of terms, or it doesn't work. Okay, so we end up then with, when we split this one up, we're going to get this term stays the same. So we have 2x squared, but our minus 15x we're going to write as a negative 12x minus 3x, right? As a minus 12x minus 3x. So when we split that up, we split it up using the magic numbers, right? Now we've got 4 terms. And all we're going to do when we factor by grouping is we're just going to split these terms up into 2 separate groups. Okay? In the first group, we're going to factor out the greatest common factor. What is that? 2x. Okay, good. So our GCF out here is 2x. And what's left over if we factor that away? X minus 6. Everybody agree? So that's our leftover term. Okay? In the middle, we're just going to put a big plus sign because we're linking these 2 groups together. And then when we factor by grouping, we have to end up with the same leftover term in both groups. So if that's an x minus 6, then that must be an x minus 6. But we ask ourselves, what would we have to factor out of the second group to get an x minus 6 left over? We have to factor out a negative 3, wouldn't we? Okay, now Anybody tell me where we're gonna go from here? How many terms do I have in that expression? Now, we gotta really get our terminology straight here, right? When we're starting to get into this more complex math, we wanna make sure we really understand and we immediately know what we're talking about when we say terms versus factors. What are factors? Factors are things that are what? Factors are things that are what? Multiply. That's all it is. Factors are things that are multiplied together, right? What are terms? Things that are added or subtracted, right? Added or subtracted. So in this row right here, we've really just got this term plus that term, don't we? I've got two big things that are being added, agreed? Now the first term has two factors in it, has the blue factor and the red factor. And the second term has two factors, the blue factor and the red factor, okay? So when we're factoring out a greatest common factor, we're factoring out the biggest thing that divides into each term equally, right? Does anybody see a common factor in the first term and the second term there? X minus 6, right? So we could factor out of each term, we could factor out an x minus 6. Okay, now let's see what that leaves behind when we do that. If I divide away the x minus 6, what's left from the first term? 2x. If I undistribute the x minus 6, I get a 2x. And there's my plus sign that's linking the two. And what's left over in the second term? Right? So what do you know? We're done. What did we end up with? We ended up with x minus 6 times 2x minus 3. Does that look familiar? What do you know? See what I'm saying? Okay. Now, the difference here is this method is rigorous. The whole way through, what we started with is equal to each step. So it flows algebraically. Every step is correct. Really?
Probably not, but it looks so.
Okay.
Got him so excited.
Well, that's cool if you did. Let's try one more of these. How about one more of these? So let's
One
do.
more. I didn't even know what.
If there's one.
Okay. I'll tell you what. Let's do. Let's kill two birds with one stone, and let's do number on the sheet I just gave you. 3x. Add 3x. Okay, we don't want that one. Let's do number 18.
18?
Yep. Let's do number 18.
Why?
Oh, there is an 18.
Oh, this is easier than it looks.
Yeah.
No.
Okay, so to get a little more practice with this, now the only difference, this new assignment that I gave you, these new notes, it says solving quadratics by factoring. Okay, the only thing you're doing here that is additional to what we talked about yesterday and just a little bit today is that after we get the quadratic factored, we're going to apply what's called the zero product property and just set each factor equal to 0. Okay? Let's start with the factoring part, and you'll see what I mean when we get there. So the first thing we're going to do is we're going to set this whole thing equal to 0, right? So we end up with 4x squared minus 11, if I subtract x from both sides, I get minus 12x. Plus 9 equals 0. Okay, now we're gonna try to factor the left side. Okay, we gotta factor the left side. So we gotta get magic numbers. What's A and what's C? 4 and 9, so 8 times C equals 36. What's B? Negative 12, okay. So what are my magic numbers? What two numbers multiply to 36 and add to negative 12? Okay, well, specifically,
-6.
negative 6 and negative 6, okay? Negative 6 and negative 6, okay? So we can split this up then, this middle term, we can break that up into a minus 6x minus 6x, right? Plus 9, right? Okay, now what? You tell me. And it all equals 0, you're right.
Oh,
Okay, you're right. So what am I gonna do? You're right, what am I gonna do to the left side? I'm seeing I'm breaking it up into groups. So I'm breaking it up into groups. What am I doing with the first group?
finding the greatest common factor.
Greatest common factor, which is 2x. What's left over?
X minus 3.
Everybody agree? If I undistributed 2x,
Yeah.
okay, we've got our plus in the middle. Now what?
No, the greatest common factor. Oh, no, the 2x times 3.
Okay, the leftover factor has to be the same in both groups. So whatever we got here for our leftover has to be the leftover factor there. And to make that happen, what do I have to undistribute from the second group? Negative 3. Okay, so then what do we end up with? If we factor out our 2x minus 3, and this is all equal to 0, right?
Wait, why do you have to undistribute?
Say it again.
Why do you have to undistribute the negative 3?
Because I need, whatever the leftover factor from group 1 was, I need to have the same leftover factor from group 2. And the reason I need that is so I can have a common factor that I can undistribute.
I see it.
Okay? So now that I made sure that the red factors were the same, that they were common, I can factor out that common factor, and we get 2x minus 3 times what?
2x minus 2x plus the negative 3.
Okay, I'm going to get my 2x plus, okay, I got it. 2x plus negative 3. Okay, make sense? And that's all equal to 0, right? And so then what do we get? We just get, on the left side, I get 2x minus 3 times 2x minus 3. Well, that's just 2x minus 3 squared, right? Equals 0. Okay, now, where do we go from there? So here, I want to do we need a little warm-up real quick. So just leave this problem, put your pencil down for just a second. You want to do this in your head, please. We need a little quick little warm-up. Make sure we're going to have to do some mental math on this stuff. So in your head, I want you to do this, please. So start with number 5, okay, and in your head, we're going to do add 3 to that, okay? So everyone should have 8, right? Okay, multiply by 7, okay, subtract 3, multiply by 128. Come on now, come on.
I gotta write that down.
Divide by 1.2751. Okay. Multiply by pi taken out to 9 digits. And then times 0 equals what?
0.
Oh, okay. Okay, so there's an important point there, right? The only way that we can have a product that equals 0 is if one or more of the factors in the product are equal to 0, right? You can only get 0 for an answer if you're multiplying by 0. Agreed? Okay, so this is what we call the zero product property in math. So what this means then is that if I've got some factored expression that's equal to 0, the only way that could happen is if one or more of the factors are equal to 0, right? So the only way that 2x minus 3 squared could equal 0 is if 2x minus 3 equals 0. Agreed?
Yeah.
So we know then that in this case there's only one solution, and the solution is what we get when we set 2x minus 3 equal to 0. Well, I add 3 and divide by 2, and I get x equals 3/2, right?
Wow.
Wait.
Wait, can you
My
explain
brain
that?
is
Yeah,
going.
can you-
Sure. So once I get my factored expression equal to 0, then all I have to do we call this the zero product property. Oops. The zero product property says that A times B times C can equal 0 only, if and only if, and that's our way we say if and only if, A equals 0 or B equals 0 or C equals 0, right? The only way I can have a product of more than one thing, product of multiple factors equaling 0, is when the individual factors equal 0. So those are my solutions, right? In this case, I've got one factor that's being squared. So 2x minus 3 times 2x minus 3 can only equal 0 when the factor 2x minus 3 is 0. If it were anything else, any other number squared would not be 0, right? Okay, let's try another one of these. Let's try a little easier one with this, on this new assignment. So let's try one like number 6.
Oh, I was thinking 13. Hello?
Okay, so let's solve this equation. This one is already in standard form. It's already set equal to 0, right?
Yeah.
Okay, so we want to, in order to figure out what the solution is here, it's very difficult or impossible to do until I get this factored. How would I know what value of x I would square and multiply by 2 and then subtract 2 times that number and subtract 24 and have it equal 0? Who knows, right? There may not even be one, okay? But if I can factor the left side, I know that the product of factors can only equal 0 when each small, tiny, simple factor is equal to 0. So let's factor the left side. What can I do? What can I do? Okay, I can factor out of 2. We always want to try to factor out a GCF first, right? So we can undistribute a 2. So it's equal to 2 times what's left over then.
The whole thing.
X squared minus 12.
Okay? And now I'm left with a much simpler trinomial to factor, right? A is equal to 1, so I just have to find relatively simple magic numbers that multiply to, well, okay, but when I'm factoring this guy,
It's 4.
I gotta find numbers that do what? Add to -1 and multiply to -12, right? So if they multiply to a negative and add to a negative, we got opposite sign numbers. Which one's bigger? The negative. Good, and so we know it's going to be a -4 and a +3, right? Okay, so what are the only values of x then that could make this product 0? The only way we can get 2 times x minus 4 times x plus 3 to equal 0, I've got a product of 3 factors there, right? The only way, we just did a little trick here, right? I had you guys multiply all that complicated stuff out, but you knew the answer was 0 because I multiplied by 0, right? So the only way that this can work is if either this factor is equal to 0 or that factor is equal to 0. Because the only way I can multiply stuff and get 0 is when I multiply by 0.
So X is
Right.
-4 and
Right, so then by the zero product property, by the zero product property, we know that either x minus 4 equals 0 or x plus 3 equals 0, right? So what are my solutions? X equals 4 or x equals negative 3.
Oh, I remember that.
Okay? Just ringing a bell?
Yeah.
Okay.
Oh, what do I do with that?
Well, even if it doesn't, that's okay. I mean, if this is new, that's fine. But this is the important thing here. The reason that factoring is useful to us in algebra is because when we're able to set an expression equal to 0, so it's got to be equal to 0. If we can factor whatever's on the other side, the product of those factors can only equal that 0 when each of the individual factors is 0. Okay? Now, one other thing about this. Did that 2 really contribute to the answer? No, because 2 is a constant. 2 can never be 0. 2 is 0. Only the factors that had variables in them could ever equal 0, right? We could choose the correct values of x that make those factors equal 0, right? So what else could we have done? Kind of plan B, couldn't we have said at this step right here, we could have just divided each side of the equation by 2, couldn't we? Before we ever even factored it, we could have rewritten that as x squared minus x minus 12 equals 0 and solved that one instead, right? Okay, is that okay to do? Sure. Because when we're solving an equation, all we're trying to do is find the values of x that satisfy the equation, right? The solutions. Does it matter that this expression right here is different than this one? No, not a bit, because they have the same solutions, right? So the moral of the story is when you're solving an equation, you're free to divide both sides of the equation by a number. That's okay. What we cannot do, though, is we can't divide both sides of the equation by a variable, right? Because if we divide both sides by a variable, we would have lost a solution. We can't do that. But you can always multiply or divide both sides of any equation by a number to make it simpler. Okay? Yes, sir?
Could you have made the 3 negative, or does it have to be 4?
It has to be the 4 because positive 4 times negative 3 equals negative 12, but it doesn't add to negative 1.
Oh, I got it.
Right? It has to add to b. Okay?
The answer is 4.
So these are the answers. Or better yet, I should say the solutions. Okay? Want to do another one?
Yeah.
Okay, let's do another one. Number 1. Okay, let's do number 1. We'll do as many as we can get through in class today. This is going to be a quick one. It's already in standard form. It's a really simple one to factor. What's the only thing I can do? Factor out an x. In fact, if I've got 2 terms like that, it's not a trinomial. I don't need magic numbers, right? All I can ever look to do if I have 2 terms is either factor something out, or the other thing is what I didn't quite get to today. So it's using patterns. I'm going to have to do that on Monday. So here's what's going to happen with your homework. I'm putting up a homework for the first section. You're going to be able to do all the problems except maybe not like the last 4 or 5, because those are the ones. But I'll make the due dates like the middle of the week next week, okay? The assignment over this stuff, same thing. You'll be able to do most of the problems. But you're going to run up against a couple of them that you won't be able to do because we haven't talked about the difference of squares or sum of squares patterns. But you can do most of the first 2 assignments based on what we're talking about today. Okay? Yes?
If we're going to retake things like math tests, can you still do that?
Yeah, you bet. You bet. Okay, so tomorrow, probably tomorrow. I won't be here tomorrow, but if not tomorrow, you can do it next week, and that's fine. Or up to the end, it's fine. Yeah. Okay, so what about this one? You told me to factor out an x. What's left behind if I do that?
X plus.
Okay, so then, what are the solutions? We have 2 factors here. We're just going to set each of the factors, and here's kind of a cool way to show this. Let's just put a line down here, and we'll set each factor equal to 0 and find the zeros. So if I set x equal to 0, that's it. I just get x equals 0 as an answer. if I set this side equal to 0, I get x equals -9. There are my two solutions. Because by the zero product property, once I get the left side factor, I set each factor equal to 0. Those are the solutions of the, right? Okay?
Why did it change to a negative?
Because when is, you tell me, when is x plus 9 equal to 0? When x is -9,
Oh, okay.
right? Do you really have to write that out? No, not in an honors algebra 2 class. You guys can do that in your head. You could ask yourselves, x plus 9 equals 0 when x equals what? And just write the answer down. You don't have to show that little bit of work. You can if you want it, but you don't need to. You can do that part, solve those little simple linear equations in your head. Now, do you see the big advantage here, though? Look, we end up with, rather than having to find solutions of this big ugly quadratic, when we get it broken down into these small simple factors, I'm trading one big ugly equation that's difficult essentially for two small simple to solve equations that give me the solutions directly, right? Okay? Do we have time? Let's do one more. See if we can squeeze in one more here. Okay, I want to do... Okay, let's do 14. Okay, here we go. I need you with me. I want to get through one more. So what are the steps I got to do here? First step always is set it equal to 0. I've got to put it into standard form. So if I subtract x and I subtract 4, I get x squared plus 10x plus 25 equals, oh, that is a bad one. I don't want to take this one. Okay, well, we'll just have to do it.
Oh, man, I figured it out.
And so then I'm going to factor the left side, right? And the left side, my magic numbers are going to be x plus 5 times x plus 5, right? And so what are my solutions going to be? -5 and -5. I get the same solution twice. And so my answer is just going to be just -5. Okay? Makes sense? But what if these had been different factors? Then I would have gotten 2 solutions.
Yes.
Eventually, later on in the year, when we have 3 factors, we'll get 3 solutions.
Where did the 25 go?